Today we're going to be talking about how to go from grams of one thing to moles of another, or from moles of one thing to grams of another. Since we're dealing with two different compounds, we do need a balanced chemical equation. As you see, I've already provided those. And since we're going to be dealing with masses of some sort, I've already gone ahead and calculated the molar mass of the compound that I need. We're going to go ahead and we're going to translate this English version of the question into math. How many turns into x? Theoretically, if my pen would work. And then it says grams of O2, that just stays grams of O2. Are needed to react with are my bridge words. They just tell me that these numbers are going to be related somehow. And then 7 moles of H2. Okay. So I see that the only two compounds that I actually wrote about were oxygen and hydrogen. So I'm going to go ahead and I'm going to underline those two compounds, and I'm just going to go ahead and visually connect them. What I'm going to do now is I'm going to create my Multum Ol Ratio, because I know that I'll need to jump between those two compounds at some point. So the coefficient in front of H2 is 2. So I'll say for every 2 moles H2, I have 1 mole O2. Remember that this invisible coefficient is 1. I can also say for every 1 mole O2, I have 2 moles of H2. Now I'm going to go ahead and I'm going to pick the version of the conversion factor that allows me to leave moles of H2. I'm going to go ahead and I'm going to pick this one because it has moles of H2 on the bottom. So I'll go ahead and plug that in. I'll say 1 mole of O2 to every 2 moles of H2. Moles H2 will cancel, leaving me with moles O2. I'm going to check to see if this is actually the unit that I wanted. I see that I am currently in moles of O2, but I stated that I wanted grams of O2, so I'm not quite done. So I'm going to go ahead and I'm going to extend this train track so I can continue. And now I need something to go from moles to grams, and that's where this molar mass is going to come in. I'm going to rewrite it in the two ways that I could use it. I could have 31.998 grams of O2 per 1 mole of O2. Or I could have, for every 1 mole of O2, 31.998 grams of O2. I'm just going to pick the one that will allow me to cancel the unit that I want to. Moles of O2 is the current unit that I'm in. I don't want that unit anymore, so I'm going to pick the version of the ratio that allows me to cancel moles of O2. That will be the one that has moles of O2 on the bottom. So I'm going to pick that first ratio. So I'm going to pick 31.998 grams of O2 on the top and 1 mole of O2 on the bottom. That allows me to cancel moles of O2, leaving me with grams of O2, which was the unit that I said that I wanted, so I can go ahead and plug this in. Remember that we multiply everything on the top, so that would be 7 times 1 times 31.998, and then we divide by everything on the bottom, so that's 2 and 1. So if we multiply 7, 1, 31.998, and divide by 2 and 1, then I am left with the number 111.993. Let's go ahead and round to 2 decimal places. So I'm going to count over 1, 2. This is the last number I care about. Look over to see if I need to round up. 3 does not make me round up. So what I'm going to do is I'm going to just drop that 3 and I will report 111.99. Unit is important, can't report naked numbers, so 111.99 grams O2 would be my final answer. Okay, my next problem, I again have a balanced chemical equation. I've already calculated the molar mass of the necessary compound, and we're going to go ahead and see what we need to do. So it says how many moles of potassium bromide, so I'm going to turn that into X mole potassium bromide. I'm going to set it equal to the number given in the problem, so that's going to be 32 grams of potassium sulfate. And I'm going to go ahead and I'm going to set up my train tracks. Now I see that I'm currently in grams of potassium sulfate and I need to get to moles of potassium bromide. Those are two different compounds, so I'm going to go ahead and I'm going to find those two compounds in my actual equation. I'm just going to go ahead and connect them and create the Multum Ol Ratio because I'll know I'll need it eventually. The number in front of potassium sulfate is 3, so I'm going to go ahead and say 3 moles potassium sulfate. For every 6 is the number in front of potassium bromide, so I'm going to say 6 moles of potassium bromide. Or I could also say for every 6 moles of potassium bromide, I have 3 moles of potassium sulfate. I'm not ready to use this information yet though because I'm in grams. So since I'm in grams, I need to get out of grams to actually be able to use these Multum Ol ratios because I don't have moles to cancel yet. So I'm going to go ahead and I'm going to turn this molar mass into the two versions of the ratios that I could use. So I'm going to say for every 174.198 grams of K2SO4 potassium sulfate, there is 1 mole. And for every 1 mole of potassium sulfate, there is 174.198 grams of potassium sulfate. I'm going to go back in and add this here since I skipped that on accident. Okay, so I need to pick the version of my ratio that allows me to cancel out grams of potassium sulfate. That's going to be my second one just because it has grams of potassium sulfate at the bottom. So I'm going to go ahead and write it. I'm going to say 1 mole of K2SO4 at the top and 174.198 grams K2SO4 potassium sulfate at the bottom. Now grams of potassium sulfate will cancel, leaving me with moles of potassium sulfate. Now what I need to do is I need to pick the version of the ratio that has moles of potassium sulfate at the bottom. That's going to be the second version. So I'm just going to go ahead and plug that in. For every 6 moles of potassium bromide, there are 3 moles of potassium sulfate. This allows me to cancel out moles of potassium sulfate, leaving me with moles of potassium bromide. Now I'm going to go ahead and I'm going to check. I see I'm in moles of potassium bromide, which is the unit that I said that I wanted. So I can go ahead and stop plugging stuff into this train track and actually plug it into the calculator. Everything on the top, 32 times 1 times 6, and divide by everything on the bottom, so 174.198 and 3. So when we plug that into the calculator, we'll do 32 times 1 times 6 divided by 174.198 and 3. That will give me the number 0.367398018. Okay, that's a pretty gross number. I'm going to go ahead and I'm going to round it to 2 decimal places just because I feel like that's a good place to start. 1, 2 places after the decimal, that's the last number I care about. And I'll look over to see if I need to round up. 7 does make me round up, so this number turns into 0.37. And then finally I need to address this unit, and I'm going to use the only English that's left in my math and the only unit that I said that I was looking for. So this will be 0.37 moles of potassium bromide. Okay, let's do another problem where we're looking for grams. Here I'm going to have, again, my balanced chemical equation and then my actual problem. It says how many grams of CH4, that's methane. So I'm going to say X grams methane, CH4, are needed to produce 27.4 moles of H2O. So CH4 and H2O are the only compounds that I care about. I'm going to go ahead and connect those. And since I know I'm going to have to go between those two compounds at some point, I'm going to go ahead and I'm going to create those Multum Ol ratios. Coefficient in front of CH4 is 1. It's invisible, so I'm going to go ahead and I'm going to write it. I'm going to say 1 mole CH4. And the coefficient in front of water is 2, so I'm going to say 2 moles H2O. And I'm going to restate that as 2 moles H2O for every 1 mole CH4. Okay, I see that I'm in moles of H2O, which means it's appropriate for me to go ahead and use the Multum Ol ratios now. I just need to pick the Multum Ol ratio that actually has moles of H2O at the bottom. It's going to be this first version. I'm going to go ahead and plug that in. So 1 mole of CH4 will be on top, and 2 moles H2O will be on the bottom. Moles of H2O will cancel, leaving me with moles CH4. That's not the unit that I said I wanted, so I'm going to go ahead and I'm going to use this molar mass. This is not an appropriate setup for the molar mass to be plugged in here, so I'm going to go ahead and I'm going to write it as a ratio. For every 16.043 grams of CH4, there's 1 mole of CH4. Or for every 1 mole of methane, there is 16.043 grams of methane. Now I need to pick the version that allows me to cancel moles of methane. That's going to be the version that has moles on the bottom. That's going to be this version. I'm going to plug it in. 16.043 grams CH4 per 1 mole CH4. Mole CH4 will cancel, leaving me with grams of CH4. That is the unit that I said that I wanted, so I can go ahead and plug that into the calculator. Again, everything on the top will be multiplied, so 27.4 times 1 times 16.043 divided by everything on the bottom, so 2 and 1. So 27.4 times 1 times 16.043 divided by 2 and 1 gives me 219.7891. I want to go ahead and round it to 2 decimal places here, so I'm going to go ahead and look over to see if I need to round up. 9 does make me round up, so I will rewrite it as 219.79. This number needs to be addressed with a unit. I will look to see what unit I want and the unit I'm left with. They should be the same at this point, and I'm going to go ahead and use it. So it's going to be 219.79 grams methane. Okay, very last problem. I have my balanced chemical equation again, and I'm going to go ahead and see that it says how many moles of O2. So I'm going to say X mole O2 are needed to react with 52.4 grams of phosphorus. Phosphorus and oxygen are the only 2 that I care about, so I'm going to go ahead and I'm going to connect them and make my Multum Ol ratio, because I'll know I'll need it at some point since I have 2 different compounds here. So for every 4 moles of phosphorus, there are 5 moles of oxygen, or for every 5 moles of oxygen, there are 4 moles of phosphorus. I'm not in an appropriate unit to use this conversion yet. Right now I'm in grams. I would need to be in moles in order to use these Multum Ol ratios. So I need to go ahead and get out of grams and into moles. How do I do that? Molar mass. I already calculated the molar mass off screen here, so I'm going to go ahead and just turn that into a ratio that I can actually use. So for every 30.974 grams of phosphorus, I have 1 mole. Or for every 1 mole of phosphorus, I have 30.974 grams of phosphorus. Now I'm going to pick the version that actually allows me to cancel out grams of phosphorus. That will be this second version. And I'll plug it in. 1 mole of phosphorus will go on top. The 30.974 grams of phosphorus will go on the bottom, allowing me to cancel out grams of phosphorus. Now I'm currently in moles of phosphorus. That's not quite what I wanted. I wanted moles of O2, so I do in fact need that Multum Ol ratio. I'm going to pick the version that has moles of phosphorus at the bottom. That's going to be that second version for me, so I'm going to go ahead and plug it in. So for every 5 moles of O2, I have 4 moles of phosphorus. Moles phosphorus will cancel, leaving me with moles of O2. Multiplying everything on the top, so 52.4 times 1 times 5, divide by everything on the bottom, 30.974, and 4 will give me 52.4 times 1 times 5 divided by 30.974 divided by 4. Okay, that gives me 2.114676826. Lots of sixes. Okay, so this is my gross ugly number. I don't want to report this gross ugly number. I'm going to report a number that has 2 decimals, 1, 2. This number is the last one that I care about. I'm going to look over to see if I need to round up. 4 does not make me round up, so I will report 2.11. Then I need to address this number with a unit. Should be the last English thing in your math, and it should be the thing that you said that you wanted in the very beginning. So 2.11, and then moles O2 will be your final answer.